Hi, in this particular video we're going to be looking at the paper 2 for the November 2017 Edexcel Foundation paper. As always, please do stop the video, have a go at each of the questions and then compare your solutions. Each of the videos in the playlist is going to be about 20 minutes long. It's going to give you the opportunity then to have a go at each of the questions and spend about an hour's worth of fairly focused revision. If you do need any additional support, please don't hesitate to leave a comment. I'll always come back to you, or have a look on the rest of the channel, and there's lots of other videos with some more examples. I'll look forward to seeing you inside the video. Hi, in this set of videos we're going to be looking at the November 2018 Foundation paper from Edexcel. This is actually paper 2 and it is a calculator paper, so please do stop the video, have a go at each of the questions and then compare your solutions. I'm going to aim for this video to be about 20 minutes long or so. That should give you about an hour's worth of focused revision if you have a go at each of the questions. Okay, let's move on then with question number 1. All right, let's have a look then. And we've got right down the value of the 4 in the number 542.3. So if you pronounce it like that, you might hear that 42. Okay, so it's actually 4 tens, so we call that 40, and that would be fine. Okay, number 2 then, write down a square number that is also an odd number. Well, you've got quite a few to choose from, so any square number would be something like 2 times 2 is 4, which is actually an even number, or 3 times 3, which is 9, which is an odd number, so you can actually use 9, but you could also choose 25, 49, all this sort of stuff as well if you wanted. Okay, question number 3, change 4,560 grams into kilograms. Well, there are 1,000 grams in a kilogram, so all we're going to do is we're going to basically divide by 1,000 by moving the decimal point 3 places, 1, 2, 3, so that would give us 4.56 kilograms. Hopefully that's okay for you. And then the next one, part B, is change 7.3 meters into millimeters. Well, little bit tricky with this one. So basically what I'm going to do is I'm going to convert that into centimeters first. Okay, so there are 100 centimeters in a millimeter. So I'm going to move the decimal point 2 places. So that's going to be 730 centimeters. Okay, now if I want to convert that into millimeters, there are 10 millimeters in a centimeter. So again, I move the decimal point 1 more place to multiply by 10, and that's going to be 7300 millimeters. Okay, hopefully that's all right for you. Number 4, now it is a calculator questions, calculator paper, so you could use your calculator to work this one out, work out the cube root of 64, and all you need really is just the cube key on your calculator, which is actually this little yellow one here. You can access this by pressing the shift and then this button will give you that. Okay, and the cube root of 64 is going to be 4. Okay, next one then, write 0.31 as a fraction. Well, this is the hundredths column, so this is 31 hundredths. Okay, 31 out of 100. You don't need to reduce that, you can't anyway, but you know, sometimes it might be worthwhile just reducing it if you see it. Okay, so question number 6 is going to be a very standard GCSE type question. Write all the fractions in order to size. Well, the problem you've got here is you've got different denominators. Now, it sort of lends itself to doing either converting them all to the same denominator, or if you're using a calculator, you could convert them all to decimals. So 3/4 as a decimal is 0.75. A 5/7 as a decimal, if I just use my calculator here, if I press this, I'm going to be able to write the fraction of 5/7. Hopefully you can see that on the video. And then if I press the SD key here, it will convert it for me to 0.714285 recurring. Okay, so I can do that with all of these questions, and I can kind of cycle through each of these fractions, and I'll get 0.71, 0.76, and then the last one is 0.73 recurring. Okay, so now it has asked you to write the fractions down in order of size. So the first one is going to be this one, 5/7. The second one is going to be 11/15. The third one is going to be 3/4. And then the fourth one is going to be 19/25. Okay, do please make sure you answer these questions. If it asks you to write them as fractions, then please do write them as fractions. Otherwise, you'll lose a mark on that. Okay, all right, let's have a look at number 7 then to simplify this. So what we're doing here is we're gathering together the like terms. And in this particular case, I've got 3m minus m, which is 2m, minus m, which is 1m, plus 3m. Well, that's 1m plus 3m is going to be 4m. Okay, part B, simplify 2 times n times p times 4. Okay, well, 2 times 4 is 8, and that's 8 times n times p, which we write as 8np. Okay, hopefully that's all right. Let's move on then to question number 8. So a map has a scale of 1 centimetre to 14 kilometres. So on a map, the distance between Manchester and London is 18.8. Okay, what is the real distance? So what we're saying is that we've got, here's Manchester up in the north there, and then we've got London in the south. Okay, and the distance on the map is actually 18.8 centimetres. So if you measured that with a ruler, that's what you would get. Okay, however, for every centimetre, that equals 14 kilometres in real life. So if we want to know the actual distance, what we're going to do is we're going to say, well, we've got 18.8 centimetres, and we're going to multiply that by 14, and that's going to give us 263.2 kilometres. Okay, hopefully that's okay for you and you're able to work that one through. Quite a common question. In fact, actually this particular page, page 2 or page 3 actually on the test, is quite common question. So well worthwhile practicing all of those. Okay, so please do stop the video, have a go at each of these questions, and then compare your solutions. We're about 7 minutes into the video. We're going to keep going until about 15-20 minutes, something like that, and see how we get on with it. Okay, so the nth term of a sequence is 3n plus 4. Explain why 21 is not a term in this sequence. All right, so there is a couple of ways of doing this. What I'm going to say is that actually, for me, the easiest way is that if n is in the sequence, it's going to have a particular place. It's going to have a particular term. Sorry, if 21 is in the sequence, it's going to have a particular term. It's going to have a place in the sequence. Okay, so what we would say is actually 3n plus 4 equals 21. Okay, so the nth term must equal 21 if it has a place in the sequence. So if I minus 4 from both sides, I'm going to get 3n equals 21 minus 4 is going to be 17. Now, the problem with 17 is it's not divisible by 3. And if it's not divisible by 3, it means that n isn't a place. It doesn't exist. It's not a term in the sequence. So we could write here, explain why. Well, n is not a whole number. Okay, so 17 divided by 3. And that would be perfectly fine. You're basically saying that it has to be a whole number, and therefore it isn't. If it was something like 21, it would be the number 7, in which case it'd be the 7th place. Okay, well, it's not, it's 70. Okay, here are the first 3 terms of different sequence. Write down the 2 numbers that could be the 4th and 5th term in the sequence. Give the rule you've used to add your numbers. Well, there are a couple of different options with these. Okay, so the first one would be, let's say 7 and 11. Now, the reason that would be is because what we've done is we've added 1, added 2, and add 3 and add 4. Okay, so what I mean by that is we've added 1 to go to 2, then we've added 2 to go to 4, and then we add 3 to go to 7, and then from 7 we add 4 to go to 11. Okay, so that's a possible sequence that we could use, or a rule that we could use. Okay, the other one that we could have is we could just add 1, add 2, add 1, add 2. So there's quite a few variations on these. So add 1, add 2, and then back to add 1, add 2. In other words, if we add 1, we're going to get 2. Okay, and then we add 2, we're going to get 4, then we're going to add 1, so we're going to get 5, and then we're going to add 2, so we're going to get 7. So that's a possible one. Okay, you can have a bit of fun with these, I guess, if you wanted to. Another one which might be perhaps a little bit easier to deal with is we could double each time. Okay, so if we doubled each time, you can see here that 2 times 1 is 2, and 2 times 2 is 4. So 4 times 2 is going to be 8, and 8 times 2 is going to be 16. So providing you've come up with one of those and you've written out the rule, that would be perfectly fine. Okay, so let's have a look then at question number 10, where we've got an input-output machine. Okay, so here's an input machine. Work out the output when the input is 8. So in other words, we're putting 8 in here. 8 times 5 is going to be 40. And then 40 minus 2, so it would mean the output is going to be 38. Okay, hopefully that's all right for you. So work out the input when the output is 28. So this time I've got an output of 28. Well, 28 is a result of minusing 2. So what we've got to do is we've got to add 2. So that then would become, if you like, at this point, 30, because 30 minus 2 would be 28. Okay, and then this number is as a result of multiplying by 5. So what we're going to do is divide by 5, which would be 6. So let's just work that backwards then. So if we say 6 times 5 is 30, and 30 minus 2 is 28. So therefore the input must have been 6. Okay, so a little bit of a puzzle on that one, but you know, worthwhile working through. Occasionally I do see number machines on these sorts of questions. Okay, let's move on. We're about 12 minutes into the video, so let's have a look at question number 11. So question number 11, Adam gets a bonus of 30% of £80. Katie gets a bonus of 24. No, beg your pardon, 28. Okay, work out the difference between the bonus Adam gets and the bonus Katie gets. Okay, well, we know Katie gets 28, so that's absolutely fine. Let's work out what Adam gets. So what we need to do is we need to look at Adam's bonus, which is 30% of £80. Well, 10% of 80 equals 8. So therefore 30% I've multiplied by 3. So I'm going to times that by 3, and 30% of 80 is going to equal 24. So Adam's bonus is actually going to be £24. Okay, so to work out the difference, Katie gets 28, Adam gets 24, so the difference is going to be £4. Okay, hopefully that's okay for you. Let's have a look at the next one then. So there's 49 counters in a bag. Okay, we've got 20 of the counters are red, the rest of the counters are blue. So at that point, I would kind of stop and just say, in that case, there must be 29 blue counters in the bag. If 20 of them are red and the rest are blue, it must mean that 29 of them are blue. So if one of the counters is taken at random, find the probability that the counter is blue. Well, the probability is going to be there are 49 counters, but 29 of them blue, so 29 out of 49 would be the answer to that question. Remember that when you're reading a fraction, it is 29 49ths. Okay, you could read it as that, but sometimes it's better in your mind to say 29 out of 49, and that would be perhaps a little bit easier, particularly these sorts of questions. Okay, let's move on then to question number 13. Okay, so question number 13, a square has an area of 81 centimeters. So the thing about that is that area is where we multiply two sides together. Now, because it's a square, all of the sides must be the same. Okay, so let's have a look at multiplying two numbers together to get 81, of which both numbers are exactly the same. Well, those two numbers are going to be 9. Okay, because 9 times 9 is 81, and also it is a square, so therefore it must be that this length is the same as this length, which is also incidentally the same as that length and that length. So if we want to work out the perimeter, it's going to be 9 plus 9 plus 9 plus 9, and that's going to give us 36 centimeters as the perimeter. Okay, so a little bit of difference between the area of an object or a shape and then the perimeter. The perimeter is the outside edge. Okay, hopefully that's all right. Let's move on then to question, or part B of the question. Okay, this whole question is worth 5 marks. It is worthwhile having a good go at these sorts of questions. Okay, so the diagram shows a right angle triangle and a parallelogram. Okay, the area of the parallelogram is 5 times the area of the triangle. Okay. All right, the perpendicular height of the parallelogram is h. Find the value of h. Okay. All right, let's have a look. So before we go any further, let's work out the area of the triangle. Okay, well, the area of the triangle, and I see this in a couple of different ways. You're either going to write the way I learnt it, which is a half base times height. Okay. I've not spelled height correctly there, have I? H-I-E-H-E-I? I don't know. Okay. Or you're going to write it as base times, no, it is that way, isn't it? Height over 2. Okay, it's got me confused now. It's because I'm concentrating more on the maths than I'm on the English. Okay, yeah. So it's either going to be a half base times height or base times height over 2. It doesn't really matter. They're exactly the same. Okay, so let's work that out. So the base is going to be 9 and the height is going to be 16. Okay, so I am right. H-E-I. H-E-I. Yes, I am right. Okay, so it's going to give us a base of 9 and a height of 16, all divided by 2. So therefore, the area of the triangle itself is going to be, if you pop that in the calculator, 72 centimeters squared. Okay, that's the area of the triangle. However, what we're told is that the area of the parallelogram is 5 times more than the area of the triangle. So the parallelogram, area of parallelogram, okay, is going to be equal to 5 times 72, which equals 360 centimeters squared. Okay, now what we've got to do is figure out this value of h. Well, the value of h in a parallelogram, which is pretty much exactly the same as a rectangle, it's just kind of sloped off to one side, is going to be this 30 multiplied by the height. If you can imagine this was a rectangle, okay, and the area is 360, this bottom bit is 30, so h is going to be the perpendicular height. Okay, so what we're saying is that 360 is equal to 30 times the height is equal to 360. Okay, sorry about my writing there. Okay, so if we want to work out the value of the height, what we're going to do is take 360 and divide it by 30. So the height, which is h, is equal to 360. I'm going to write it as a fraction, okay, because I just find it a little bit easier to do that, but you might prefer to write it as a division. But 360 divided by 30, however you do it, is going to equal 12. Okay, so therefore the height is going to be 12 centimeters on this particular question. Okay, hopefully that's all right for you. So 5 marks on that particular question, well worthwhile having a go at that. Okay, let's move it on. We are about 20 minutes into the video, so I'm going to do just a little bit more because I know that you're enjoying this so much and we're all having fun. Okay, so Victoria throws an ordinary fair 6-sided dice once. The probability of getting a 3 is half the probability of getting a 6. Well, no, it's not. Okay, now the reason it's not is because the probability of getting a 3 is 1 out of 6 if it's a fair dice. It's exactly the same as getting a probability of a 2 or a 1 or a 5. They're all exactly the same. That the probability is for each number, the probability would be 1 out of 6 if a fair dice. So I'm afraid Victoria is incorrect. Okay, hopefully that's all right for you. If you just imagine throwing a dice, it's just going to be fair. Okay, so Andy throws the dice twice. He says the probability of getting 6 on both throws is 2 out of 6. Is Andy correct? No, he's not, I'm afraid, because the probability on the first throw of getting a 6, so if I put first throw, is going to be 1 out of 6. The probability on the second throw, throw. I do know how to spell throw. Okay, it's going to be 1 out of 6 as well. Okay, so the way we work out probabilities is we multiply the probabilities across. So 1 over 6 multiplied by 1 over 6, the probability is going to be equal to 1 out of 36. Okay, all right. My writing today is dreadful, my spelling particularly. Okay, so Indri throws the dice once. She also throws a coin to get heads or tails. List all the possible outcomes that she can get. Okay, well, let's look at the dice. Okay, so the dice is going to be either a 1, a 2, a 3, a 4, a 5 or a 6. Okay, so that's her throwing the dice. Okay, but when she throws the coin, she can get either heads or tails. So she could get 1 heads, 2 heads, 3, 4, 5 and 6. Okay, however, there's also a possibility she can get a dice number and then tails as well. So that's going to be 1, 2, 3, 4, 5, 6 on the dice, but this time tails on the coin. Okay, all right, hopefully that's all right and you're happy with that. So let's move it on to question number 15, and I think we might stop at 50. I don't know, let's have a look. We might, you never know. Okay, please do stop the video, have a go at this question and then compare your solution. Again, a very popular type of question. So Remy invests £600 and he's going to do it for 5 years in a savings account. So at the end of 5 years, he's received a total of £75 simple interest. Work out the annual rate. Okay, so what we're saying is that if he receives a total of £75 at the end of 5 years, then 75 divided by 5 means that he gets £15 each year. Okay, don't be fooled with that one. You've got to be very careful that you make sure that you figure out how much he's going to get each year. Okay, so the interest rate is going to get £15 out of £600 which he originally invested. Now that's the actual fraction. Okay, so £15 out of £600 that he originally invests. Okay, and then we're going to multiply that by 100 to get the percentage, and that's going to give us 2.5. So he's going to get 2.5% interest. Okay, there are some videos on a playlist on the channel for simple interest and compound interest. Please do have a look at those. They are very popular kind of practical maths sorts of questions, so they are well worthwhile having a go at. Okay, I think we'll do number 16 because it's hopefully relatively straightforward, and then we'll stop the video at this point. So describe fully the single transformation, and the key issue here is it is a single transformation, so it's just one thing is happening that maps shape A onto shape B. Okay, well hopefully you can see that if you put a mirror along the x-axis here and you looked into the mirror from this side, if this was a mirror along here, what you would see is this reflection of this reflection B. Okay, so what we're saying is it's a reflection of shape A in the, and this thing here is called the x-axis. Okay, this line. All right, so hopefully that's okay for you. Not too bad for 2 marks. Well worthwhile having a go and practice these things. Again, they sort of crop up, not as often as the simple interest and compound interest questions, but certainly you might get reflection questions. Okay, I hope it's been useful to you, this particular session. Please do like the video. It's really appreciated. It keeps YouTube very happy. I hope you found it useful. If you're not sure about anything, always add a comment below and I will come back to you, and I'll look forward to seeing you in the second video where we're going to start from question number 17 onwards.